continents, as the continents abducts carbonate-rich ocean floor beneath the moving continent, the metamorphosis of that ocean floor into other rocks releases CO2 through volcanoes and seltzer springs. And the sink of CO2 is the weathering process, which the rivers carry sediments to the ocean, and the chemical reactions associated with that deposit carbonates on the ocean floor. But that process does not need to be in balance at any given time, depending upon mainly the strength of the sources. And so when India was going through this ocean, this was extremely carbonate-rich ocean floor, and the CO2 was increasing, the planet was getting warmer until India crashed into Eurasia and started pushing up the Himalaya mountains and the Tibetan plateau, and so the source then slowly diminished and the planet cooled off. And the lesson from that is that while the natural changes, the natural imbalance between the source and sink can be of the order of 1/10,000 of a ppm per year. And in a million years, that's consistent. It becomes 100 ppm change. But the human-made rate is now 2 ppm per year. So we're orders of magnitude more powerful than the natural changes in CO2. So humans now control future climate. Now, to show some examples of the global observations of what's happening in the last few decades, we see that the amount of sea ice in the Arctic it fluctuates from year to year, but it's decreasing quite substantially, and has decreased about 30%. And within a few decades, we will probably have no sea ice left in the Arctic at the end of the melt season. The last year and a few years ago, we twice had this Northwest Passage open as the amount of sea ice has decreased. The melting on Greenland we can now observe from satellites, and that fluctuates from year to year, but overall the area is tending to increase. And that meltwater on Greenland will go to a low spot on the ice sheet, burrow a hole in the ice sheet, and lubricate the base of the ice sheet, speeding up the discharge of these giant icebergs to the ocean. And that's one of the processes that's contributing to the mass loss from the ice sheets. The mass of the Greenland ice sheet increases during the winter as the snow piles up, and then during the melting season it loses mass. But overall, it's losing mass at a rate that seems to have increased over the period since the gravity satellite began to measure the mass of Greenland very accurately. And similarly, Antarctica seems to be losing mass at not quite as fast a rate, but again, the rate seems to be increasing over the period of data. Another expected effect of global warming is an expansion of the Hadley circulation, rising motion in the tropics and the subsidence which causes the subtropics to be dry. That circulation cell is expected to expand. And empirically, averaged over all longitudes, it has expanded by about 4 degrees of latitude. And I think that's one of the reasons why Lake Mead and Lake Powell are only half full. That expansion of the subtropics is affecting the Mediterranean region, the southern United States, and in the southern hemisphere, Australia and parts of Africa. Of course, the weather patterns fluctuate from year to year, and this is a La Nina year, which may contribute to the droughts in Texas. But this drying in southern United States is, I think, at least partly related to this trend due to global warming. And the climate models, this is an example which does show that, that not only Mexico and the Mediterranean region, but central the Midwest U.S. is likely to experience more extreme droughts in the future. But of course, and that's the reason why both in southern United States and western United States, the fires are covering more area and burning hotter. There are other things that contribute to that, but the same is true in the Mediterranean region, in Greece and in Australia. At the same time, of course, as the atmosphere becomes warmer, it holds more water vapor. So at the times when you do get rainfall, you get more extreme events, and therefore you get more extreme floods. So both ends of the hydrologic cycle get strengthened by global warming. And the glaciers all around the world are melting back. In the Rocky Mountains, the Andes Mountains, the Alps, the Himalayas. And it has practical importance because these, during the dry season, more than half the water in rivers like the Ganges and the Brahmaputra is from melting ice. So once the glaciers are gone, the dry seasons are going to be much drier. The rivers are going to tend to run dry. Another effect is on coral reefs, where both the warming of the ocean surface causes the corals to expel symbiotic algae, and which they require to live.